about his hobbies, let's call it this way. He said that in his free time he likes building from the Lego blocks. And about the talk, all projects start small. Some of them grow big, and how to manage the complexity, how to manage them. And as an answer to this question, could be XcodeGen as help for you. And this will be the main topic of the talk. So XcodeGen, Why and How by Sebastian Osiński.
Hi everyone. Let me just plug in my computer. Okay, so by the attendance today, I see that the after party yesterday went well, but I hope not too well for some of you. So as you see, welcome to my presentation about XcodeGen, Why and How. As Evelina introduced me, I'm Sebastian Osiński. What's going on? Of course, the presenter doesn't work. Yes, it works. I'm senior iOS engineer at TopTal, and today I'll talk about XcodeGen. First, I would like to issue a warning. This presentation, despite the name of this conference, will contain no Swift code. But it will contain a lot of YAML code. So if you do not like it, I think it's the last point you should leave. But I don't want that. Okay, so let's go to the why part of this presentation. So why would you even want to use XcodeGen? And the answer for that is that we have lots of problems when using Xcode. Working with Xcode poses many problems, and one of them shows up when we start collaborating with our colleagues. Lots of you here probably work on your projects in a team. Most of us do not work alone. We do that so the progress is faster, so we can churn features simultaneously. And we expect something like that collaborating will make us faster and stronger. But often it ends up with this, with merge conflicts in our projects, which might slow us down. And as merge conflicts are unavoidable in our code, why would we want them in our project? So we want to find a solution for that. The next problem we have is related to modularization. When you think about modularization of your project, you think about something like that, nice structure of modules related to each other, using each other. But in reality, in Xcode, it looks more like that. You have list of targets and a bunch of settings for those targets. You have to manage them. And the problem with managing those targets, those settings, is that most of the time you leave most of the settings unaltered, but there is some peculiar setting you might change. And it's easy to forget about this change because it's hard to document that change in Xcode. So we would also like to find a solution for that. And here comes the how part of this presentation. And of course, how is XcodeGen. And XcodeGen allows you to say goodbye to your Xcode project. You won't be bothered with it at all, basically. And you say welcome to Project YML. Project YML is a configuration file which XcodeGen uses. So I'll in a second show you how to use it. So what exactly is XcodeGen? XcodeGen is a tool which allows you to generate your Xcode project based on a configuration file written in YAML or JSON. In this presentation, I will focus only on YAML, as the difference between both of them is between YAML and JSON. In this case, it's not not relevant. And to be honest, YAML is a bit better for this purpose, which I will explain in more detail later. What else? The config file you will be dealing with is editable, readable, and manageable by you. Because when you deal with Xcode project and you have to merge it, it feels clunky because this format was not, to be honest, it does not feel designed to be dealt as a source code. It was only meant to be dealt with when you edited it through Xcode. And the project YML, you can edit it by yourself. And to be honest, the mergeable part is just an afterthought because in most cases, you won't have any conflicts in your project YML because first, you won't edit it that much because you once set it and then you leave it. And even if you will change it, there won't be many cases where you would change it simultaneously with one of your colleagues. Okay, so how to use XcodeGen? Of course, first we need to start with installation of XcodeGen. You can use that. You can do that through Brew. I prefer Brew, but you can also use Mint or SPM, or you can just compile it yourself from the sources. And after installing XcodeGen, we start writing our project YML. This will be a very simplified version of project YML with just only basic targets. So let's go through it. First, you start with defining your project's name. This is going to be the name of the project which will be generated by XcodeGen. Then we define some options. There is a plethora of options which XcodeGen supports, but here I just showed you two basic ones, like bundle ID prefix, which allows you to specify the bundle ID for all your targets. So in this case, each of my targets will begin with dev.osiński. I mean, their bundle IDs will start with that.osiński and then the name of the targets. So for example, presentation target will have the bundle ID of that.osiński.presentation. Then we have deployment target, which will also apply to all targets. And as I mentioned, there is lots of options, but this is just a simplified thing. And then we go to the main point of projects YML, which is targets. So here we are how we define the targets. It's just a simple dictionary-like structure with various keys which describe your target. So here we have my app target. To create it, I just need to provide that it's a target of type application. There are many types of targets. Most of the time, you will probably use application, maybe framework for your submodules, and unit test target. And then we specify platform, of course, iOS in our case, and it can be macOS, watchOS, whatever you use. And then we define our sources. So it's going to be directory where all your sources for this target are. So all your Swift files or your Objective-C files and so on. It also includes your resources like images and images, maybe some audio, video you include in your project. And XcodeGen has some built-in heuristics which allows it to decide if this particular file is a source file or resource. And of course, you can alter that with further options. You can also provide many directories for sources. You can provide some exclusion rules. Later, we define dependencies. So our app target depends on presentation and domain targets, which we define underneath. And again, we define them by just providing type, platform, and sources. After we write our project YML file, then we need to run XcodeGen. And the command is simple, just XcodeGen generate. After you run it, XcodeGen will generate your Xcode project for you, and then you can open it in Xcode and work with it as usual. The main thing is that if you want to introduce any changes to Xcode project, change some build setting, add some target, you do that through XcodeGen. You do not edit Xcode project at all. And you should include it in your getignore or if you use any other VCS, ignore it in your VCS. So you should not commit your Xcode project from that point. And after running XcodeGen generate, and you opening in Xcode project in Xcode, you have like your normal project as always, you can see that we have dependencies set between the main target, the app target, and the domain targets, domain and presentation target I declared in project YML. There is a problem though in this, what I showed you. It's kind of repetitive. Like for every target, I needed to define platform, I needed to define where the sources are, and so on. Thankfully, XcodeGen provides a solution for that. It's called templates. Templates allow you to bundle the shared settings for your targets in a template, yeah, in a blueprint, which you will apply to targets. So let's see how we can create a template. So templates are basically written the same as you would write a target, just under a different key in your project YML. You do not write them in targets, you write them in target templates. So you start with the name of your template. So here I have two templates which I created. First one I just called base module. It's my name. I came up with, and it just contains the platform and the sources. So this template tells that each target which inherits from that template will have the sources, its sources in a directory of the name of this target. So if we have our presentation target, which inherits from this template, it will have its sources in presentation directory. The $target name variable is something which XcodeGen provides you and fills it for you. Then I define the second template, which, what's funny, inherits from my first template. So you can mix and match the templates. You can mix and match the templates, and that just adds one more thing, that each target which implements this template will have a type of framework. So now we can go to our project YML again and update it to use targets. First thing, I include to use templates, not targets. First thing I do is I include the file with templates. You can define templates in the same file in your project YML, but a good practice is to extract it to a separate file and just include it. So all the configuration is a bit cleaner. And then we go to our targets. So our app target did not change that much because we only got rid of sources and platform, and but we replaced it with templates. Still, we need to provide the type and dependencies, but it's mostly a case for your application target, as it's not. It's kind of unique for your project, and you do not have many targets like that in your project. Contrary to your other targets, like here we have presentation and domain, and we shorted them just to a declaration what template they use, and that's all. Yeah, that's all. That's all. What you might see when I implement the template, I write it under the key called templates, not template, because each target might implement many templates. So you can create for your project many small templates and just mix them and compose them to create your targets. For example, in one of our projects at TopTal, we have small templates. We just add pre-built script, specific pre-built script to given target. Okay, so what else XcodeGen can do? Because what I showed you for now was just the basic configuration. And no even remotely complicated project cannot go without specifying some build settings. And you can do that in XcodeGen too. You use the same keys you would see and use in build settings pane in Xcode. You just provide them in your project YML. You can use the predefined keys you would find in Xcode. You can also provide your own name of the keys if you happen to use them in somewhere in your project. And what's nice in here is that you can comment. You can put comments in your project YML, so you can give context for some why specific settings is set in that way. Because probably everyone here had some case where the project didn't work for some reason, and you found some obscure Stack Overflow post which told you that this build setting should be set that way for that configuration, and you would set that, but after a month or two, you wouldn't remember why was it set that way. You might put it in your README or somewhere else, but the best place for comment is just next to the change. So you can do that in project YML. And of course, you can provide different settings depending on your configuration files. So you can provide values for debug, for release, or any other configuration you might use in your project. Next thing, XcodeGen not only generates Xcode projects for you, but it also generates info lists for you. Because let's be honest, info lists are also projects configuration. So including them in the same place as the rest of the projects makes sense. And by default, XcodeGen generates an info list for you with predefined properties, the basic ones. But you can alter that process by providing your own properties or changing the path where the generated info list will be. If you don't like this behavior of XcodeGen generating the project for you, generating info list for you, you can opt out of it completely and just manage your info list by yourself. The same thing with entitlements. The entitlements file also can be generated by XcodeGen, the same as info list. You just provide an entitlements key with the contents, and it generates it for you. What else? Build phase scripts. XcodeGen also can do that for you, but with this additional advantage of being able to extract those scripts into files. Because let's be honest, editing those scripts in this small editor in your build in Xcode is not a great developer experience. Now you can extract them into a separate file, edit it there, track it in Git, and just include it in your project YML. And during the generation, XcodeGen will copy the contents of the script into resulting Xcode project. And if your script is very simple, you can also provide it inline as you would do in Xcode. You just provide the shell command to run. And of course, you can provide any type of script which Xcode supports right now. So pre-built script, post-compile script, post-built scripts. So what else? This is something not many of you might use, but we use that at TopTal, and this is something which was kind of a deal breaker for us when deciding for a tool to modularize our app. We have a very specific setup for UI test in our project, which involves including Earl as a sub-project of our project. We couldn't do that through CocoaPaths. We had to do that as a sub-project and then referencing the targets from Earl. So XcodeGen allows you to define that your project imports some sub-project, and then you can use targets from that project later in your configuration. This is something I wasn't at the time able to do with Tuist, because this was the other tool we considered. And it also can do much, much more. Here in the background, you see the documentation of XcodeGen. Probably anything you can think of doing in Xcode, it's possible in XcodeGen. And to be honest, this is one of the best documentations for iOS tools I've seen. Probably only GRDB tops that. I really recommend checking the documentation of GRDB, but okay, I digress here. And let's go further. So you might ask yourself, okay, I've generated my projects, but I have external dependencies. What about them? how XcodeGen and package managers work together. And I have to say they work really well. So let's start seeing how they work. With Swift Package Manager, you just define your dependencies from SPM in your project YML. You define them on top of project YML, and then in your targets, you just put this package as a dependency. And it works, after opening it in Xcode, it works as usual. If you use cartridge, you just use your cart file as usual, and then just reference those libraries in your targets just with the cartridge keyword. If you use CocoaPods, it's a bit different story, because let's go through how CocoaPods work. When you run pod install, CocoaPods also edit your project, the same project XcodeGen just generated. It also creates XC workspace for you. So to be honest, the solution is simple. You just need to run pod install after each time you generate your XcodeGen project. And thankfully, XcodeGen allows you to automate that process. When you create your project YML, one of the options you have is called spotgen command. And here you can provide any kind of shell command which you want to be run automatically after the XcodeGen finishes generating your project. So if we run XcodeGen generate, it generates our project as usual, and then automatically installs our pods. And from that point now, you use it as usual. Okay, so this sounds really fun when you have a nice project, a nice new project which you just started. You do not have any, let's say, craft collected with your project. And what if you have existing project? And so how can you migrate your project to XcodeGen? And from my experience, it's neither easy nor very hard task, because you have those two, let's say, layers of migration. You have this superficial layer of your targets in Xcode. You can just open Xcode, see your targets, and write them down in your project YML. But what about all the build settings underneath? What about scheme settings and so on? There is lots of hidden options, and finding them in Xcode is not that easy. Like you will forget about one of them. Thankfully, we have another tool called XCdiff. It's a tool written by developers at Bloomberg, which, as the name suggests, it's a very aptly named tool. It allows you to run diffs between two Xcode projects. So in our case, we would run XCdiff with the project we had before introducing XcodeGen and the project the XcodeGen generated for us. And after we run it, XCdiff gives us a rundown of all the differences between those files. So here we see that we have some discrepancies in file references, or we have some differences in project configuration for debug. And this allows us to find those differences. But of course, this does not tell us much. Like based on only that differences, we won't be able to fix that. Thankfully, XCdiff has an option called verbose. When you provide it, it gives you a detailed difference between projects. So here I run the XCdiff on my original Xcode project and the generated one. And it tells me that in debug configuration, I have a discrepancy in deployment targets. So I just need to go to my project YML and fix that. Later, my project has, my new project, the generated one, lacks organization name. So I just need to go to project YML, put that there. And so on and so on. And with those little steps, you'll manage to make those the old project and the new one exactly the same or similar enough, because you might, through this process, you actually might find some setting which was redundant in the first place in your original project. So what about good practices of using XcodeGen? I have few to show you. First thing is speeding it up a bit. XcodeGen provides you option to use cache. So it caches both your project YML file and your project's file structure. And if any of those changes, then only then it runs the generation. Otherwise, it will be a no-op. This speeds up the process a lot because generating a project might take a while, like a few seconds, especially if you run some post-gen commands, for example, pod install. If nothing changed in your project, you don't want to run pod install again. This allows you to fix that. And the next good practice is using Git hooks. XcodeGen generate will be a command which you will use a lot. Each time you switch branch, check out new commit, you should run Xcode generate, because one of your colleagues might have added a new file, so you need to run Xcode generate, so it's included in your Xcode project, so you can run your project. Or they might have changed your project YML, so again, you need to run Xcode generate. But doing it by hand, it's kind of error prone. Like you can forget about running that and then start to wonder why doesn't it work at all. So thankfully, Git allows you to provide something called Git hooks. Git hooks are scripts which Git will run for you on specific actions. So here I provide a Git with something called post checkout hook. And each time I check out the branch, Git will run XcodeGen generate for me. So after it finishes checking out, I'm good to go and I can work on my project. And combined with use cache, it should not impose any significant speed penalties for checking out your code. And the third good practice is just splitting your project YML into multiple files. Like having one big configuration file is not a good thing to manage. And with simple includes, you can split your project into separate files. Here is an excerpt from our configuration at TopTal, where we decided to divide our project YML into 4 files. So our project YML itself just contains the simple settings like the team ID, organization name, and so on. But the meat itself is in those separate files. So first we have our templates, where all our templates are defined. Then we have our app, it's a file with our app target and its tests. Then we have a file with modules, so our modules like presentation, domain, networking, and so on, plus their tests. And then we have a separate file with our UI tests. As I mentioned before, our UI tests are, the setup is fairly complicated, so separating into a separate file, separating into a separate file, was a good choice here. Now I will move to a slide, which might be a weird slide in a presentation which basically advertises a tool, but how to get rid of that tool if you decide. So I think this is something which you should consider every time you decide to include any third-party dependency in your development pipeline. What if I need to get rid of it? How hard would it be? Because we do not want to be locked in by a third party. What if XcodeGen stops being maintained? What if Apple decides that they completely revamp Xcode projects and they stop using that format, so this won't be applicable again? It might happen. And thankfully, due to the nature of XcodeGen, it's very simple. So you just run XcodeGen one last time, so you have the freshest version of your Xcode project. You add the Xcode project back to your Git, so you start tracking it, and stop using XcodeGen. You just uninstall it, and from that point, you can either manage your Xcode project with Xcode, or you might consider using different tool, for example, Tuist. And speaking about Tuist, as I mentioned, we evaluated both tools, XcodeGen and Tuist, which one would be better for our needs at TopTal. And just as a closing note here, I would like to present you some short comparison between those tools, which might give you a starting point if you decide to look for a tool for managing your Xcode project. So first, XcodeGen, the configuration file for it is written in YAML or JSON. I recommend using YAML, as JSON is kind of a bit more verbose due to its nature in this case, and also writing comments in JSON is by itself, by the format, it's not supported. So you need to kind of go around it if you want to include some comments. But XcodeGen is simple. Like the file structure, the project file structure I showed you, it's very it's just hierarchical. You use the dictionaries and arrays and just that. But due to the language used, which is the configuration language which is used, the YAML or JSON, it's sometimes hard to debug because you do not have any support from compiler. So if you make any typo in a key name or something like that, you won't get feedback until you either try to run XcodeGen generate, and XcodeGen generate will give you an error, which sometimes are not that descriptive, or the project might generate, but it won't compile. That's not very frequent occurrence, but it might happen. However, due to its simplicity, it's fairly easy to integrate XcodeGen with complicated setups. As I mentioned, our setup for UI tests, this was our deal breaker. We could, at the time of evaluating those two tools, only XcodeGen allowed me to integrate our UI tests with it. So with Tuist, you write your configuration in Swift, so it's a great thing for us because you do not have to switch context between your code and your project configuration file. And thanks to Swift, you have first compile time safety, but also you have access to all the constructs of the Swift language, so you can create helper functions for your targets, and you can build a pretty nice DSL for your own project with Swift. However, Tuist, if you go to its repository in GitHub, it has kind of long history of breaking changes, and it wasn't something which we wanted to deal with at TopTal, and migrating our project configuration with each major version of Tuist. And due to the simplicity of XcodeGen, I don't think there will be a case where they might introduce some major breaking change. And Tuist, in our case, posed an integration problem. Because Tuist really is focused on this type safety, and in Tuist you can also include sub-projects in your project's configuration, but the project you are including has to also be managed by Tuist. So it also has to have its Tuist configuration file, And I couldn't do that with L-grade, the UI test library which we use. I couldn't migrate it to Tuist. So this was a deal breaker for us to choose XcodeGen, as XcodeGen was the one who allowed us to use that library. Okay, so thank you very much for listening to me. If you would like to learn more about XcodeGen or start to use it, you can just visit the repository of XcodeGen and also the repository of XDiv. And if you'd like to get in touch with me, you can visit my blog or just tweet me at Seb_Osiński. Thank you very much. And are there any questions?
We have a few minutes, so I see first question.
So thank you for the presentation. And I would like to ask you a question about using standard Xcode project. Can you find an example when you don't have to use XcodeGen, or it's a bad idea to use XcodeGen? Where I mean, when using standard Xcode project is better than using XcodeGen?
I feel like if you work alone and do not collaborate with others, then not using XcodeGen is a valid idea. And but if the project grows much more complicated, both in terms of the amount of the number of developers who work on it and the complexity of its configuration, then I think having it in XcodeGen is a much better idea. There is someone. Evelina, there is someone there.
Okay,
oh. Okay, sorry.
Hi. You were mentioning Xcode project, but not really workspace. Is there a support for workspaces? And what about tests, test plans, etc.?
Yes, about tests, like for the brevity here, I did not include unit tests, but of course you can define test targets, you can define settings for those test targets, you can also define schemes which will include the configuration, like the test plans, if you want to run the test randomly and stuff like that. But about the XC workspace, to be honest, I do not remember if there was a setting for generating the XC workspace itself.
Okay, and I saw a comparison with Tuist. Have you considered comparing the tool with Bazel? Have you heard of it?
Like, I've heard of Bazel, but we did not consider it at the time.
Okay.
So, thank you for the presentation. Great presentation. I have a question, and it's okay to tell me to go read the freaking documentation. But using Swift Package Manager, do you know if using local packages is supported? Or do you use local packages in your app?
Like in our current setup, we do not use SPM. We use mainly CocoaPaths. We are kind of old in terms of that, like kind of not up to date. But to be honest, I'm not sure if the local packages are supported. Okay, but I would be surprised if they weren't.
Thanks for the presentation. So when it comes to modularizing project, have you considered just using Swift Package Manager and keeping the project file to a bare minimum and using like local dependencies and the package file? Do you see it as a viable alternative, or is it like too limited for your use case?
Like, I think in some applications it might be a viable idea. In our case, we didn't want to. We just thought about SPM, but we had this approach that either we go all the way with SPM, so both in terms of our external dependencies and our project, but at the time and right now we are not able to move to SPM. So yeah, that basically.
Okay, I think I saw one more hand. Yeah, okay. Coming.
Thanks. My question was around when you were defining the structure, and you say the source is like in the app folder. From that point going forward, does it use folder references, and therefore any file you add into that location is automatically added into the project, or do you have to individually add files as you go along?
If you include the host directory, it will by default include all the files in that directory. But you can also specify some exclusion rules if you have some specific file which for some reason is in that directory, but you don't want to include it in your projects. Then you can just exclude it. You can also specify what extensions you want to support. So only all the files in this directory, but only Swift files and so on. You just use this standard like description, like with asterisks and so on.
Kind of regex.
Yeah.
Okay, short one.
Did you find a fix for re-indexing everything after XcodeGen? Because after you run it, all the indexes are removed and you have to...
I had not.
Okay.
Okay.
That's why it's a good thing to use the use cache thing, so you reduce it to minimum.
Okay, we're running out of time for questions, so thank you for the questions, and to you, Sebastian, for this talk.